Hey, welcome to the first presentation in the Year 9 National Curriculum Algebra section. I hope you did the review video and had a look at that, because this one leads on. Okay, so here you are. I'm starting off with a question for you, a red hot burning question right in the middle here. Which are the same and which are different of these expansions around the screen? I'll give you a hint. There's some colours there that might help you work that out. I'll also give you another hint. There's one expansion on the screen which doesn't belong in that colour group. Okay, I want you to pause the presentation and discuss it with your classmates and see if you can see the difference between these. Which are the same and which are different? Okay, pause the presentation, have a go. Well, what did you find? Let's have a look first of all at the red ones. There's one, and that's special, isn't it? Same first term, same second term, with the opposite sign here. We had a brief look at this in the review presentation. Let's check all the other red ones out. Yes, same first term, same second term, and opposite signs. That fits. What about this one? Oh, it's a 2x. Same first term, same second term, opposite signs. Okay, and here then, same first term, same second term, opposite signs. It looks like the red ones are of that pattern. We might have to get a name for those. We'll have a look at those later on. What about the greenies? What do we notice? Same first, same second. Hey, the thing's identical, mate. You're multiplying a number x plus 3 by itself. What's that called when you multiply a number by itself? What would you say? I think it's called a square, isn't it? Where you square something. Okay. What about another greenie? Let's try this one over here. Oh yes, identical, aren't they? Same first term in each of the brackets, same second term, and this time got a negative, but it's the same bracket. That's another square. Oh yes, that's the way, that's the one. Okay, so what about the purplies? Let's have a look here. Oh, same first term, second terms are different, and the sign's different. There doesn't seem to be a regular sort of pattern to that one. What about this purpley? Same first term. Oh, the second terms are different, the signs are different. So that's not going to give us a pattern, is it? From our FOIL, our expansions of those two brackets. It's not going to give you any particular pattern. This is the same problem, same first term, this is different. It's the same sign here, but that's not going to give you a pattern either when you multiply it out. You might check that and see if there's any particular pattern. What about this purpley over here? Same problem. Okay, they're the same. These two are different, and the signs are different. We won't be able to get a pattern out of that one. What about the last purpley? Did you see it? This was the one I spoke of. That does not belong in the purple group. What group does that one belong in? Can you see? It's the red group, isn't it? Because the same first term, same second term, the signs are different. It's the red group. All right, do you get the idea? What I want you to do in this presentation is to be alert to the nature of the expansions and the terms that make up the brackets there in the expansion. Come down and let's have a look. Screen clippings here are from Hayes and Harris, so publications of the Year 9 National Curriculum book, and you should have that handy by. Let's have a look at what we've done now. We took this type. Hey, it's got a name, difference of two squares. I wonder where that comes from. Let's study it again. A plus b by a take b. A by a is a squared. A by neg b, missed that one, is neg ab. B by a is plus, oh, what have they got? I wanted to write ba. Is that the same as ab? Think about that one. Well, let's do an example up here. 2 by 3, yeah, is the same as 3 by 2. That's right, so we could write AB instead of BA. So it looks like this one here, because you're going to see what's going to happen in a minute. And we call that process when an operation like multiplication, the order doesn't matter, we call that commutative. The order in which you do things does not matter. Okay, so addition, it doesn't matter. Subtraction or division, it does matter which way around you put the terms. We'll have a look at some of that stuff later on. And then the last term is b by neg b is neg b squared. And look at what happens here. Neg AB plus AB, we found this in the last presentation. That cancels itself out there. So we get no middle term. The middle term's disappeared. Hey, that's where the name comes from. The name is based on the answer. What you finally end up with is the first term squared minus the second term squared. What about this perfect squares expansion? Well, perfect square, that name is related to or based on what the original expression looks like, not the answer. This is a square, isn't it? So a plus b by a plus b, a by a squared. A by b, ab. B by a is another ab. Using the idea that b times a, because multiplication is commutative, equals a times b. And then b times b is b squared. Using FOIL, firsts, outers, inners, last, a little word there to help you remember to check off 4 terms you should have. Each one in the first bracket, as we've been doing here, multiplied by each one in the second bracket. Okay, what do you notice here? Oh, they're the same. Plus AB is 2AB plus b squared. You're doubling up. They don't cancel here. They double up because they're both the same. Can you see it? It's good to get up close and personal with maths so you don't have to memorise stuff. Okay, here we go. So here's our first and second terms here. You could go straight to this without working out, couldn't you? Because they're identical, the square, you're going to get the first term squared and twice the product and the second term squared. What about a take b squared? I've just got some scribble here, get rid of that. A take b squared. A take b all squared. I'd like you to pause the presentation and have a go at showing this one here. Alright, pause it now. Okay, coming back, a by a is a squared. A by neg b is neg ab. Neg b by a is neg ba. And neg b by neg b is plus b squared. Just notice that, it's always plus on the end because it's neg b by neg b, and neg by a negative is positive. So what have we got? BA is the same as AB, so we've got 2 of them, both negative, so it's neg 2AB. Okay, do you get that? You might have to talk to your teacher about that. A squared take 2AB plus b squared. Is it the same pattern? Yes, it is. What are we doing? Let's put it in words so we can get up close and personal with this formula. We don't want to base our knowledge just in A's and B's because we're going to have X's and Y's and stuff later. So let's try and unpack the formula in words. What do we get? We get the first term squared plus twice the product of the 2 terms plus the second term squared. So that's what we write here with these algebraic expressions, but this is the understanding I want you to have of any formula you work with. Is it twice the product? I think somebody's going to say, hey honey, you've got a negative in there. But it is twice the product, isn't it? It's just that the product itself is negative. See this? You've got neg AB and neg BA because of that negative in that bracket there. It's still plus twice it. It's adding on 2 times neg AB. Okay, the product A times B. Okay, do you get it? Come back over here. What about thinking about this in words rather than in A and B land? What's it say? It's saying if you've got an opposite sign within the bracket, you get the first term squared minus the second term squared. It's a 2er, if you like, a 2-term job, because we got this cancelling out in the middle. So think of those word interpretations of a formula, because that means you're really getting up close and personal with the formula rather than just memorising it. And maths is fun and easier if you can get up close and personal with it. Okay, let's come down and let's do some stuff. So these are from your textbook. You can use your textbook or take it off screen. Difference of 2 squares. Okay, we know it's this pattern now because the middle term will cancel out. You could do the long way if you like, but we can say we understand that in the middle terms it'll be plus 5x and take 5x. And if you're not sure, do some expansions until you're confident. But eventually we want to go from there to there. So it's the first term squared minus the second term squared. X squared take 25. And what I like to do with classes is to have a little competition. No paper. You have to think about it in your head, exercise your mental faculties, and try to do it that way, because you're going to increase your brain power if you can make your brain work more often. Okay, 3 take y, 3 plus y. Same first term, same second term with the opposite sign. So we know we're going to cancel out the middle term and we can go straight to there or even to there. First term squared minus second term squared. Here's a question for you. Does it matter that y, the pronumeral, there's an hint, the pronumeral is in the back end of the bracket? Does it matter it's down there and not up the front? Pause the presentation and discuss that little point there. Does it? No, it doesn't, because of that word. The y stands for a number. So it's equal to 3. Well, it's not equal to 3. It's on a footing with 3. You can't pick on y just because it's a letter. It's standing for some number. So it doesn't matter where it is. It's going to behave the same as the number. So the y can be in the back of the bracket. All right, are you ready? Come down now and have a look. I want you to practice these now and do most of them. You might already be good enough, if you understand it, to just write the answer straight down. That's what I'd like you to try to do. But just do a couple and then forward the presentation and check your work. I don't want you to do them all and then find you messed them all up. Okay, so do a couple and check your answers. So I'll show you the answers now, and then I want you to come back and pause the presentation and do a few and check it as I said. Okay, so here are the answers. All right, away you go. Do most of those. I think you should do every one. Right, let's go down and look at a variation. Here's a variation. Why is it a variation? We put some 2x's in here and some 3y's in here. Is it the pattern? First term's the same, second term's the same, opposite sign. So it fits, what's it called? Difference of 2 squares. Sometimes abbreviated to difference of 2 squares. Okay, so it's the first one squared, that term, first one squared, minus, always minus in this one, second one squared. And I hope you know why it's always minus, rather than just learning it off as a rule. All right, remember the hierarchy, Huddy's hierarchy here. And this is on the introductory video on Huddy Maths. You don't just use the rule or the algorithm. You want to understand the concept and get up close and personal with it and say, hey, I really get that. I see it. I had a student in a class recently who was sitting there when I was explaining something and said, oh yeah, what a great student that was there. He got to the highest level. Oh yeah. When you can say, oh yeah, I'm on top of this, that's what I want you to be able to do. All right, so now what's the problem here? Oh, 2x squared. That's going to be a bit of a challenge. Square of a number is multiplying by itself. So it's 4x squared. Do you check that out then? Always unpack it to make sure. And ask your teacher. And 3 squared is 9. So it's a square minus a square. Difference of 2 squares. Let's have a look at the next one here. Okay, same first terms, same second terms, opposite signs. So it's one of those. It's the first term squared, so square 5. Always take the second term squared is 3y all squared. Let's check it out down here. 3y by 3y, 9y squared. Do you get it? Okay, 3 by 3, y by y if you like. Are you ready? Your turn. Here we go. Question 2 from Hayes and Harris. You can look it up in your book if you like. Okay, I've been doing a bit of doodling here. I'll get rid of that. Okay. All right, have a go. You should do all of them. Try to do it mentally without paper if you think you're good enough. But always checking after you've done 1 or 2, check ahead so you don't repeat an error. Make sure you got the right method. Okay, I'm going to show you the answers now. Okay, so toggle forward and back so that you can check your work as you go and write it in your book. Even if you're doing it mentally, record what your answer is so you can check it. All right, let's go on. It's more of the same thing, just reinforcing it. They're slightly different each time. What do you think the difference of this one is with this one? Same first term, same second term, opposite signs. Yes, so it is a pattern one like that. But what have we done? We've made it 3x and 4y. Both of them have got a pronumeral in them and a coefficient, a number in front. Does that make any difference? No. The key word is pronumeral. So even though this is 4y, y is standing for a number and so 4y is just going to behave like the ordinary number. So we put the two brackets here and we say it's the first one squared minus the second one squared. 3x by 3x, 3 by 3 is 9, x by x is x squared. 4y by 4y, 4 by 4 is 16, y by y is y squared. You get the idea. Are you getting good at this? All right, let's come down and take some problems for you to practice. Of course, it's important to practice so that you really get on top of it, get up close and personal with this stuff. Okay, have a go. Pause the presentation. Try to do it mentally. You might need to jot some stuff down for these, but try to enlarge your brain capacity by pushing it a bit. Okay, let's look at the answers. There are some answers for you. Check it, go back. If in doubt, put the two brackets down and do FOIL. Go through each of the steps and just see why the answers are what they are. All right, coming on, and what do we want to do now? And of course, practice the other one. Perfect squares. And you can tell when to use this sort of approach because it's a square. Okay, it's not the opposite sign, it's the same sign in the two brackets. So x plus 3 all squared. And we know from what we've done before, you get the first term squared, and then it's twice, because you get a middle product which is the same, x by 3. First by second, so that's twice the product plus the second term squared. So that's x squared, 2x times 3 is 6x, and then 9. Okay, what about one with a negative in front, in between the terms, sorry? So it's still the same, it's still a square, and when you multiply it out, you're going to get the same middle term, a neg 5x. So let's do it. First term squared, twice x by the other term. Just remember, 5 is not 5, its sign is in front of it. It is really neg 5, so take that sign with it. And then the second term squared, neg 5 squared. So just notice, square twice the product, which could be negative, if there's a negative in there, and then the second term squared. Just notice the second term squared, although it's negative, when you square a neg by a neg is a positive. Okay, so just notice that. That's important. Okay, are you getting the hang of it? But do you know why it works? Okay, that's very, very important. I want to put in that idea again, Honey's hierarchy. Just remember that. That's what you're trying to do. Get up there. Really understand everything that you're doing. All right, come down and let's have a look at 4 more questions on this. And a little bit of a puzzle question here in A and B land. We'll just check that out. And that one's worth discussing with the teacher and your classmates there. This one we've talked a little bit about in the last presentation. Just reinforce it, go back over it and check it out. Okay, because this gives the reason in this problem of why Anton was not correct. Okay, we talked a bit about that in the last presentation. All right, I'll show you the answers now, so pause it, have a go. As you do a problem, toggle forward to the answers and don't reinforce errors. Okay, make sure you're on the right track all the time. Right, here are the answers now. All right, a little bit to go and you've made it through. So let's have a look at variations of this perfect square one. And here's some variations, and you could have predicted what they would be. A 5x there, and put a 3x in the back of the bracket instead of the front of the bracket. Don't get fazed by that. Don't pick on little x. It just stands for a number. Okay, so 5x plus 1 squared. It's the first term in a bracket, because the first term is all of 5x. Square it, plus twice the product of 5x and 1. And the second term squared. So this is 5x by 5x is 25x squared plus 10x plus 1. 4 take 3x squared is 4 squared. Twice the product is 2 by 4 by neg 3x. And then all of, what's this? All of neg 3x squared. The second term here is really neg 3x. That neg sign belongs to the 3x. So this is neg 3x by neg 3x. So that is plus 9x squared. Remember, the numbers on the end here in these expansions, or the terms on the end, are always positive because they are squares. Do you get it? Just look at, because that's neg 3x, twice the product will be a negative in there. See if you can understand where this stuff is coming from. All right, let's go down. Here's one for you. So pause it, same process, and just check it along the way. Try to do it mentally without paper. See how well you can hold the expressions in your head and work with them. Getting a bit hard here. Some of these numbers are getting a bit big to square and so on. I'll show you the answers now. Okay, so backwards and forwards you go between the problems and the answers and checking, so you're consolidating your work there. All right, just finishing off now with this one. Oh, I think you can see here the differences here. Look at this. Already you have a squared term within the bracket. Okay, so let's have a look at this one. It's the first term squared plus twice the product of the two terms plus the second term squared. So 2x squared, let's do this down here. 2x squared squared. Okay, so a square outside here means you have to multiply the thing in the bracket by itself. So 2 by 2 is 4. X squared by x squared is x to the fourth. And then this bundle here, 2 by 2x squared is 4x squared. Then we've got 3 lots of that. Excuse me. So we've got 12x squared. And then plus 9. Okay, why does this one look different? Excuse me. You've got a number out the front minus your expansion. Here we go, 5 take. Now we don't know what we're going to take away yet because we haven't squared it. So we must do this term first before we know what the values are that we're taking away. So it's the old idea of doing brackets first, if you like. We're paying attention to this x plus 2 as being a particular term consisting of x added to 2, and then we want to square it. So let's do this. It's the first term squared plus twice the product, 2 times x times 2x, 2 times x times 2, 4x plus 4. Okay, go through the same thing every time. And we're taking it away, so we've got to take away all of these dudes. So it's take x squared, take 4x, take 4. Here we are. The square brackets in the second line remind us that the minus in front of the brackets affects all terms. We're taking away all of them. That's why we've bundled it up, so that we remember we're taking away this term, x plus 2 all squared, which means all of these dudes. Okay, so let's do it now. 5 take 4 is 1. Take x squared, take 4x. So we can leave it like that at this stage. All right, are you ready to have a go at that more interesting bundle here? So here's, and we'll finish there. We've got 6 and 7. So you've got some squares within the brackets. Okay, and then we've got some taking aways here and collecting like terms. Oh, it's all coming together here. If you can do 7, you're going very well. Now 7 you won't be able to do in your head. You'll have to use pen and paper and do the steps and make a nice mathematical journey or solution out of it. A mathematical story or solution is important. Up here, some of you may be able to do these mentally just by focusing and trying to hold the terms in your head and applying the pattern. All right, let's have a look at the answers then. Okay, so there are the answers to that set. I hope you've enjoyed this presentation. You're really coming along very well if you can get through this sort of stuff now. And we're going to keep building. I hope you're enjoying it and get up close and personal with it by really understanding the idea. And if you can't do that, you've got to talk to your classmates. In particular, you've got to see your teacher so you can get a better understanding. All right, it's cheers for now. Catch you in the next presentation.